Mars is a planet where even the sky seems alive. Its thin, almost transparent atmosphere is capable of producing astonishing phenomena that amaze even seasoned planetary scientists. One of the most impressive is a giant cloud stretching over the volcano Asia Mons. It extends for hundreds of kilometers, like a silvery plume appearing every Martian morning. This is not a trail of eruption or a plume of dust, as one might think. In fact, it is an icy cirrus cloud that forms when moist air rises up the mountainside and cools. Due to specific lighting and temperature conditions, it appears at almost the same time every day and then disappears like a mirage. Scientists have observed this phenomenon from orbit and for years tried to understand why it is so persistent. On Earth, similar clouds form over mountains when air currents encounter an obstacle. But on Mars, the atmosphere is 100 times thinner, and yet it is capable of creating such beauty. This is a vivid reminder that even in a thin world where the pressure is lower than at the highest point of Earth's Alps, there is still movement, breath, and dynamics. However, the Martian atmosphere is not just about morning clouds and cold transparency. It is known for its dust storms, colossal vortices capable of covering an entire continent. Sometimes these storms grow to planetary scales, obscuring the sun for weeks. In 2018, just such a storm led to the end of the Opportunity rover's mission. The panels of its solar batteries were covered with a thick layer of dust, and communication with Earth was lost. Dust is Mars' eternal companion. It is so fine and dry that it can hang in the air for months. The sun shines dimly through it. The sky turns ochre, almost peach-colored, and the horizon seems to melt in the haze. Scientists believe that dust plays a key role in the Martian climate, influencing heat distribution and seasonal temperature changes. Seasonality on Mars is even more pronounced than on Earth. Its axis is tilted at an angle of about 25 degrees, which causes spring and autumn, winter and summer to occur alternately in the northern and southern hemispheres. But because Mars's orbit is more elongated, one summer can be long and mild, while another can be short and sharp. In winter, temperatures at the poles drop below -120 degrees Celsius, and carbon dioxide directly from the air freezes onto the surface, forming dry ice. When spring arrives, this ice sublimates, creating streams of gas that eject dust and form intricate patterns on the surface. This is how Mars lives by its own rhythm, day after day, season after season. Its atmosphere, though thin, is full of movement. Its breath can be felt even across tens of millions of kilometers. And looking at this red sky, you might catch yourself thinking, despite its harshness, Mars is not a dead world. It simply breathes in its own way. When we look at the night sky, Mars appears as just a faint reddish star. But behind this tiny dot lies an entire history of human perseverance and technology. Over recent decades, dozens of missions have been sent there, and each one has step-by-step unveiled the secrets of the Red Planet. One of the most impressive achievements was the landing of the Perseverance rover. On February 18, 2021, millions of people around the world held their breath while watching the live broadcast of the landing. 7 minutes of terror. That's how long the entry into the atmosphere, deceleration, parachute deployment, and soft landing lasted. The craft endured hellish heat when its hull temperature exceeded 1,000 degrees, and then gently touched down on the surface of Jezero crater. And this was not just a technical victory, it was the beginning of a new chapter in the history of Mars exploration. Perseverance doesn't just drive around and take pictures. It searches for traces of ancient life, studies rocks that were once the bottom of a Martian lake, and collects samples for future delivery to Earth. Alongside it works the small helicopter Ingenuity, the first aircraft to perform a controlled flight on another planet. Its blades spin in the thin air 10 times faster than on Earth. What seemed like a crazy idea has become reality. Humanity has learned to fly on Mars, almost simultaneously with the Americans. The Chinese mission Tianwen-1 also arrived at Mars. Its name translates as Questions to Heaven, and it is perhaps one of the most poetic names in the history of space exploration. The orbiter entered Martian orbit, and in May 2021, the lander successfully delivered the Zhurong rover to Utopia Planitia. This was the first time a country had successfully landed on Mars on its first attempt. Zhurong operated longer than planned, studying the soil and atmosphere, as well as photographing sand dunes and rocky plains. With this, China joined the elite group of space powers capable of not only reaching Mars, but also operating on its surface. The Europeans, however, have not been as fortunate so far. Their ambitious ExoMars program, created in cooperation with Roscosmos, has repeatedly faced delays. The Trace Gas Orbiter did successfully enter orbit in 2016 and began analyzing the atmosphere, detecting traces of methane, a possible indicator of biological processes. But the Schiaparelli lander failed during its descent, and the launch of the next stage, the Rosalind Franklin rover, was postponed due to political and technical difficulties. Nevertheless, the project is still alive, and Europe still intends to reach the Martian surface. Today, several orbital stations circle the planet: MRO, MAVEN, TGO, Mars Express, and each one contributes its piece to the larger puzzle. MRO takes detailed images of the surface, allowing us to even see the tracks left by rovers. MAVEN studies the interaction of the atmosphere with the solar wind, helping to explain how Mars lost most of its air envelope. And TGO, equipped with highly sensitive instruments, searches for traces of gases linked to possible geological or biological activity. All these missions, like links in a single chain, connect the past and the future. Some pave the way for others, transmit data, adjust routes, and teach us to understand this world. Mars long ago ceased to be just a dream of science fiction writers. It has become a laboratory, where every discovery brings us closer to the day when the first human will leave their footprint in the red dust. On Mars, scientists are constantly searching for traces of past or present life, and the Perseverance mission has given us the first hints of it. The rover is meticulously exploring the bottom of an ancient lake in Jezero crater, collecting soil samples that could tell us much about the planet's past. At first glance, they are just ordinary rocks and dust, but within them lies a story billions of years old. Chemical compounds found at the boundary of sedimentary layers hint that water and complex chemical processes could have existed here once. Iron phosphates and iron sulfides are of particular interest, substances that on Earth are often associated with biological activity. This is not yet proof of life, but it is like mysterious clues left by ancient Mars. The prospect of delivering these samples to Earth remains a key element of future research. NASA initially planned a multi-stage experiment. The rover collects samples, leaves them in special containers on the surface, and subsequent missions will lift them into orbit and send them home. But today funding is limited, and the schedule for the program remains uncertain. In contrast, Chinese engineers are moving forward confidently, developing their own strategy for returning Martian soil, studying the most promising sites and sampling methods. This resembles a quiet race between two space powers, where every step could be a breakthrough in the search for Martian life. While robots explore the surface, Earthlings are preparing for their own expedition. The American and Russian Institutes of Biomedical Problems are conducting experiments on long-term crew isolation, simulating a flight to Mars. Small confined chambers become a microcosm of a spaceship, where every day is a test of psyche, endurance, and teamwork skills. These experiments create a complete sensation of an interplanetary flight. Communication delays, equipment failures, limited resources, unpredictable situations. It is a harsh school for future explorers, preparing for the moment when humans truly set foot on the red planet. But Mars is of interest not only to humans and their machines. Scientists are actively searching for microorganisms that could survive on its surface. Cyanobacteria, capable of hiding in porous minerals, are an object of close attention. On Earth, they survive in extreme conditions, from Antarctic deserts to acid lakes and the stratosphere. If such microorganisms can adapt to Martian conditions, their discovery would be a real revolution in exobiology. For now, any attempts to grow them on analogues of Martian soil show that life, even in its minimal form, is capable of finding refugees hidden from the harsh external environment. Beneath the surface of Mars lie even more mysterious secrets. Attempts to penetrate into the planet's interior face the uncompromising hardness of Martian rock and permafrost, which turns a simple drilling operation into a technical feat. The only tool left is seismology, sound waves generated by micro-movements. Meteorite impacts or internal oscillations give us the opportunity to hear the planet's internal structure. Using data collected by the French seismograph on the InSight lander, We learned that Mars has a dense metallic core surrounded by a liquid layer and a mantle. Processes continue inside the planet that once could have fueled geological and possibly biological activity. And although Mars lacks a powerful magnetic field, its inner world is full of movement, heat, and a history that humanity is only beginning to understand. Mars was once unlike what it is today. Beneath its orange-red surface, water was present. Rivers flowed, lakes spread, and moisture-saturated clays settled. Today, only traces remind us of those times: dried-up valleys, meandering channels, shiny mineral veins where streams once trickled. The rocks in these places contain hydrated salts and clays. Such minerals could not have formed without water. Every fragment of Martian soil found in ancient deltas carries the imprint of that distant time when the planet may have been habitable. Scientists are looking deeper, to where Mars's permafrost hides layers of ice beneath it. Satellite radars pick up reflected signals from subsurface layers, and among the dry sands, hints of hidden ice reservoirs are sometimes visible. These deposits may not just be relics of ancient seas, they could become the key to the planet's future exploration. After all, water is not only a source of life, but also fuel for future journeys. For future missions, ice is like gold. The search for it is underway in the polar regions and at latitudes where the sun almost never touches the horizon, and shadows have preserved the cold for millions of years. As the rovers slowly move across the ancient plains, they are like reading a stone chronicle. In places where silence now reigns, water once raged. Sediments remained, along with sandbars and dried-up riverbeds. The cameras of Perseverance and Curiosity show amazing footage. Gullies resembling deltas of earthly rivers, branching like vessels of an ancient organism. These are traces not just of erosion, but of movement. The movement of water, life, and time. In these formations, scientists see possible traces of a long-gone ecosystem that existed when Mars's atmosphere was denser and the climate milder. But the most important thing is organics. Traces of carbon compounds, remnants of the molecules from which life is born. Orbiters and surface rovers have been searching for it for decades, and sometimes faint signals are detected. Subtle, almost elusive. The organic molecules in the soil found by Curiosity were a real breakthrough. They don't directly indicate life, but they show that the chemistry necessary for it was already here billions of years ago. Perhaps Mars was just one step away from becoming a second Earth. Today, researchers dream of discovering more, not just molecules, but structure, form, patterns that will say, yes, life once existed here. For now, the planet remains silent, but this silence is filled with anticipation. Every new analysis, every image of the surface, every signal from orbit brings us closer to the answer. Perhaps the answer is hidden beneath a thin layer of dust, in the cracks of rocks, in a frozen droplet of subsurface ice. And when humanity finally hears this answer, the history of Mars will become part of our own. A story of life that could have been, and that perhaps still is. When it comes to life on Mars, scientists increasingly think not of Martians, but of microbes. Those tiny, almost indestructible forms of life that on Earth can survive where everything else perished long ago. From scorching hot craters to the eternal ice of Antarctica, microbes seem to have tamed the impossible. They grow in acid lakes, feed on sulfur, withstand radiation and vacuum. Therefore, when we say life on Mars, we are talking precisely about them, about an existence that could be hiding in the dust, in the tiny pores of rocks, beneath a thin layer of frozen soil. Scientific laboratories around the world are turning into small analogues of another planet. In sealed chambers, they simulate the Martian atmosphere: cold, low-pressure carbon dioxide. Earthly microorganisms, cyanobacteria, archaea, fungal spores, are placed inside. Many die immediately, but some remain alive for weeks. The hardiest seem to only awaken. They form microcolonies, hide in cracks and between crystals as if finding their home there. These experiments prove that life is not so fragile. It can fall asleep, freeze, but not disappear. And if it can handle similar conditions on Earth, why couldn't it survive on Mars? There are those who have gone even further. In research centers, microbes are subjected to extreme radiation, immersed in liquid nitrogen, dried to a dusty state, and then revived again. And they come back to life, as if there is no boundary between life and death for them, only a pause. These beings are living messengers of resilience, a reminder that life doesn't need warmth and comfort to exist. It only needs a tiny niche where it can cling to the edge of oblivion. This understanding changes the very perspective on the possibility of life on other planets. If microorganisms can survive under rocks in the Antarctic desert, if they withstand radiation similar to that on Mars, then perhaps somewhere beneath the surface of the red planet, in icy caverns in salt layers, or deep beneath the soil crust, their Martian counterparts are still dormant. Maybe billions of years ago, when rivers flowed and seas sparkled on Mars, these microscopic life forms already existed. And when the planet cooled, they simply went deep underground, to where the water doesn't evaporate, where it's dark but stable. Today, the search for such organisms continues. Orbiters are looking for areas where ice reaches the surface, and future missions plan to drill deeper than ever before. Because if somewhere in the frozen dust, a tiny trace of organics is preserved, a spore, a molecule, the imprint of an ancient cell, it will be a discovery that changes everything. It will prove that life is not an exception, but a regularity. That it is born where there is at least a drop of water, a little time, and at least one chance to survive. And then Mars will cease to be just a red desert. It will become a mirror in which humanity will see its past for the first time, and perhaps its future. Mars is a world frozen in time. Its surface seems to have preserved the planet's history in layers of dust, rock, and craters. Every hill, every crack is a scar from events that occurred billions of years ago. Unlike Earth, where wind and water erase traces of the past, Mars keeps them almost untouched. Here you can see everything, from ancient lava flows to craters that have remained unchanged since the time life was just beginning on our planet. On the horizon rises Arsia Mons, an extinct giant, one of the tallest volcanoes in the solar system. Its brothers, Pavonis and Ascraeus, stretch along the equator, aligning in a perfect line like a necklace of frozen fire. And towering above them all is Olympus, a colossal volcano almost 3 times the height of Everest. Once, it spewed lava, flows hundreds of kilometers long, and the surface around it resembles a petrified ocean of stone. These colossal formations are evidence that Mars was not always cold and dead. Beneath its crust, energy once raged, a hot mantle raised domes, and the planet breathed with heat. Now this breath has almost faded, but the InSight mission helped us hear what remains, the planet's pulse, the quiet vibrations of its inner world. A small seismograph installed on the Martian plane detects tiny tremors, Marsquakes. They sound like echoes from the depths, where rocky layers still shift, compressing and cracking. Sometimes these signals are born from meteorite impacts, other times from the planet's own internal processes. With each new impulse, scientists peer deeper, trying to understand what lies beneath the red planet's crust. Thanks to InSight's data, an astonishing world beneath the Martian surface has been revealed. Its crust turned out to be thicker than Earth's, like a shell protecting the inner heat. Beneath it lies the mantle, rich in olivine and pyroxene, minerals that once formed ancient volcanoes. And at the very center, the core, liquid, dense and scorching hot. It consists mainly of iron and sulfur, and perhaps light elements that prevented it from solidifying completely. It was this liquid core that once gave Mars its magnetic field, which it later lost. The field disappeared, and the solar wind began slowly stripping away the atmosphere, turning a living planet into a desert. Nevertheless, even now, heat remains in the depths of Mars. Thermal currents rising from the depths nourish ancient volcanic regions and may even keep subsurface ice in a liquid state. And this heat is like the breath of the past, quiet but unextinguished. It reminds us that even dead worlds are not truly dead. They live by their own rhythms, move and whisper through stones and dust. And by listening to these signals, we seem to touch the heart of another planet, cold, but still beating under an endless sky. Mars has long ceased to be just a red dot in the night sky. Today it has become an open space laboratory, where technology and discoveries are intertwined in humanity's endless experiment. It all begins in orbit, where satellites circle like invisible guardians of the planet. They observe, map and analyze. High-resolution cameras mounted on the Mars Reconnaissance Orbiter and the Trace Gas Orbiter capture every crack, every crater, every change on the surface. This data is like the planet's pulse, allowing scientists to see what is impossible to observe from Earth. But the real revolution is unfolding right on the Martian ground. The small drone Ingenuity, created as a bold experiment, became the first aircraft to take flight in the skies of another planet. Its rotors spin at an incredible speed in the thin atmosphere, as if beating against an invisible glass. Every flight is a step beyond the possible, every hover, proof that engineering can challenge nature itself. Ingenuity has become the eyes and scout for the Perseverance rover, unveiling new routes and research areas ahead of it. Their duo, a machine on wheels and a machine in the air, has become a symbol of a new era in planetary missions. Meanwhile, sample analysis technologies have reached incredible precision. Perseverance drills into rocks, collects samples and hermetically seals them in metal tubes. These small cylinders contain the planet's history, frozen in dust and minerals. Scientists hope that these samples may hold traces of ancient organic matter or chemical clues, pointing to the past presence of water. The rocks from the bottom of the ancient Jezero crater are pages of the Martian Chronicle, which humanity is holding in its mechanical hands for the first time. But the main goal lies ahead, to bring these samples home. The Mars Sample Return Program will unite the efforts of NASA and ESA to send a new mission to Mars that will collect the tubes, deliver them to orbit, and then to Earth. This will be the most complex operation in the history of space exploration: orbital capture, automated docking, and a return flight across millions of kilometers. When the sample capsule enters Earth's atmosphere and touches down, it will not just be a scientific event, it will be the moment when Mars literally touches Earth. Every new technology, every flight and every analysis brings us closer to unraveling what Mars was like and whether it could ever have been alive. And there is something symbolic in this. Humanity is studying another planet to better understand itself, its courage, curiosity, and eternal desire to go where no one has gone before. Of all the planets in the solar system, it is Mars that has occupied a special place in the human imagination. It was nearby, a bright red dot in the sky, easily visible even to the naked eye. And in this scarlet spark, people have always seen not just a cold ball of dust, but a mirror of their hopes and fears. First, ancient priests named it after the god of war. Then astronomers saw seas and canals on it, and imagination filled in the rest with cities and civilizations. Mars became a symbol of another life, perhaps hostile, perhaps astonishingly similar to our own. In the 20th century, it migrated from telescopes to the pages of books and cinema screens. H.G. Wells' The War of the Worlds made millions believe that an invasion from Mars was only a matter of time. In these stories, Mars was a threat, an alien mind looking at Earth with envy or contempt. But later, with the advancement of science, the image changed. In the films and novels of the latter half of the century, it became a place we ourselves strive to reach. From Ridley Scott's The Martian to science fiction epics about colonization, Mars transformed into a metaphor for survival, courage, and an insatiable thirst for knowledge. Why does it captivate us so? Perhaps because it resembles Earth, only a little older, a little colder, a little more lonely. Mars is like an abandoned house on a neighboring street. Once, life may have thrived here, and now only traces remain. And we want to return there, turn on the light, and see what's inside. Every image from an orbiter, every grain of sand found by a rover, evokes the same feeling as that experienced by ancient astronomers, awe in the face of a mystery. Scientific reality today shatters many romantic notions. There is no breath on Mars, no vegetation, no sounds except the wind. But strangely, this is what makes it even more appealing, for where there is no life, it can be created. Where there are no cities, they can be built. Where there are no legends, new ones can be written. And if Mars was once the stage for imaginary wars, it has now become a field for dreams. The dream that humanity can transform a lifeless world into a new home. Mars continues to inspire poets, directors, engineers, and scientists. It has become a symbol of humanity's eternal striving for the impossible. We look at it from Earth and see not just a planet but a destination. And perhaps one day, when the first humans step onto its surface, someone will look up at the sky and see a blue dot in the distance, Earth, and realize that the circle has been closed.